Welcome to Math Olympiad problems. Okay, this is the part 9. We'll try to cover maximum trigonometry problems in this. Okay, and as I always say, this is for the students from 8th class to 12th class. All of them can understand this. For 8th class students, it will be little advanced, but uh, 10th onwards, I think this should be everybody should know these things. Okay, let's get into the problems. Yeah, first problem. Sin square a plus 3 cos a minus 2 equal to 0. Then what is cos cube a plus sec cube a? Okay. So this is the given problem. So looking at this, let's solve it in two ways. Okay. First way is obviously there is a sine, there is a cos, two variable term. So better to convert into one variable term, right? So write sine square a in terms of cos square a, which is 1 minus cos square a. Okay. Now you can clearly see there is a quadratic equation forming in cos a as variable cos a, correct? So we can write it as cos square a minus 3 cos a plus 1 equal to 0, which implies if I apply quadratic formula, I'll get cos a equal to 3 plus or minus square root of uh, b square minus 4ac is 9 minus 4 divided by 2. So this is 3 plus or minus square root of 5 divided by 2. But if you clearly look at cos a value cannot be more than 1. It is in the range of minus 1 to plus 1, correct? Equal to, okay, less than or equal to here, okay. So cos a should be only 3 minus square root of 5 divided by 2. This is the only value possible because the other one is more than 1. That's not possible. So once you know this value, okay, secant a is reciprocal of this one, 2 by 3 minus square root of 5. If I just multiply numerator and denominator with 3 plus square root of 5, what I will get is exactly 3 plus square root of 5 divided by 2. Okay, cos a is 3 minus square root of 5 divided by 2. Sec a is 3 plus square root of 5 divided by 2. Now you have these two values, so it is just a matter of cubing them. Okay, so once I cube is, I will get this is a minus b whole cube, a plus b whole cube, right? So I get only the two terms. Okay, the negative terms gets cancelled with the positive terms. So which two terms I'll get 3 cube and plus 3 into 3 into square root of 5 square. Okay, these are all two terms I will get. So 2 times this number, and the denominator is obviously 2 cube, so 8. So if I simplify it, I'll get 18. Okay, so this is the answer. This is the one way of solving the problem. Uh, I just want to show other way. Okay, so this is same. We convert into cos a. Okay, and this is the quadratic equation you get in the cos a variable. Okay. Now here I can write it cos square a plus 1 equal to 3 cos a. Correct? If I take this 3 cos a to the other side and then divide this cos a, you take it to LHS side. It will divide cos square a by cos a, which is cos a plus 1 by cos a. This is nothing but secant a. Correct? So cos a plus secant a equal to 3. Once you know this, you just have to cube it. Correct? If I cube it, I'll get cos cube a plus sec cube a plus 3 cos a sec a into cos a plus sec a, right? This is 1. We know cos a into sec a is 1. And this value is 3. Okay, from here I can get it is 3. If I substitute all these values, I'll get cos cube a plus sec cube a equal to 27 minus 9, which is 18. Okay, so this is the other way to solve the problem. We can choose any one. Okay. We will go from a little bit easy to harder problems. So just first, it's like a brush up for your trigonometry problems. Okay, next. Okay, the upper 3/4 portion of a vertical pole subtends an angle of tan inverse of 3 by 5 at a point in the horizontal plane through its foot and at a distance 40 meters from the foot. A possible height of the vertical is. Okay, for 8th class student, probably you think what is tan inverse. Okay, tan inverse is simple. It's just if tan theta equal to 3 by 5, theta is equal to tan inverse of 3 by 5. That's it. Okay. So if I draw the diagram looks like this. You have a pole AB, okay, and upper 3/4 part, that is 3 by 4 H. This subtends an angle of, here it is theta 2. Theta 2 is nothing but tan inverse of 3 by 5. Okay. And other part subtends an angle of is this one, theta 1. Okay, rest of the part. And the foot of the pole is around 40 meters distance from the point where angle is subtended. Okay. Now what we need to find is this h. Okay. So clearly we can see rectangle triangles formed here. Okay. So first thing is theta 2 equal to tan inverse of 3 by 5 or tan theta 2 equal to 3 by 5. Tan theta 2 is equal to 3 by 5. So tan theta 2, that is here. Okay. Next. Theta 1 is nothing but AC minus OC, correct? AC minus OA, sorry. AC minus OA, which is h by 4 divided by 40, which is h by 160. Now you have tan theta 1 and tan theta 2. What you need is tan theta 1 plus theta 2, correct? So this is the formula for tan theta 1 plus theta 2. Tan theta 1 plus tan theta 2 divided by 1 minus tan theta 1 into tan theta 2, which is equal to h by 40. This is total height is h, opposite, correct? This is the theta 1 plus theta 2 and adjacent is 40. Now you substitute the values here. Okay, h by 160 plus 3 by 5 if you substitute and simplify, what you will get is quadratic equation in h square, which is h square minus 200h plus 6400 equal to 0. H is equal to either 160 or 40. Okay, these are the two things you will get. So height of the vertical is 40 meters or 160 meters. This is the answer. Okay. In trigonometry, it's very important to draw the correct diagram. Once you draw the diagram, most of it is easy actually. Okay. Next. AB are in the range of 0 to 45 degrees. What is the maximum value of sin A minus B plus 2 sin A plus B? Okay. So to solve this one, you need to know one formula. Okay. Uh, m sin theta plus n cos theta range is minus square root of m square plus n square to plus square root of m square plus n square. This formula you should know to solve this problem. Once you know this is very simple. Okay. Let's say k equal to given value and I am expanding the sin A minus B, which is nothing but sin A cos B minus sin B cos A plus 2 times sin A cos B plus 2 times sin B cos A, because this is 2 times sin A plus B. Okay. Now I can simplify. These are all, there are common terms. So if I simplify, I get k equal to 3 sin A cos B plus sin B cos A. Okay. So I can write it in two ways. This is one way. I am writing in terms of sin A and cos A. Quotients are sin B and 3 cos B. That is nothing but m and n for me. M and n are 3 cos B and sin B respectively. Okay. If I take this way, okay, what is the maximum value? Square root of m square plus n square. So which is k equal to, maximum value of k is equal to 9 cos square b plus sin square b, which is nothing but I'll get 8 cos square b, then 1 cos square b plus sin square b is 1, right? And I know that cos square b range is in 0 to 45, its range is 1, correct? Its range is 1, okay? So if I substitute that, I should get maximum value of k as square root of 8 plus 1, which is 3. This is the maximum value I should get. But you just observe, there is a sin A also here, right? Which is up to 45 degrees we are restricting. For cos, for cosine 0 degrees is maximum, but sine 45 degrees is not maximum. So there will be a problem. So just to cross check this value, we are taking maximum value at b equal to 0, correct? So cross check this value, b at b equal to 0, k equal to 3 sin A cos 0 plus sin 0 cos A, which is equal to 3 sin A, and 3 sin A maximum value you will get is 3 by root 2, because A is also up to 45 degrees, 0 to 45 degrees. So this is the maximum value you'll get. So obviously this is not the answer. Okay. So let's check the other way now. The other way is k is same equation I take, but now instead of taking sin A and cos A as variables here, I am taking cos B and sin B. Okay. Now coefficients for me are 3 sin A and cos A. These are the coefficients. Okay. So if I take these coefficients, okay, now I am left with the maximum value of k equal to 3 9 square root of 9 sin square A plus cos square A. Okay, now I am left with square root of 8 sin square A plus 1. Here I am left with cos B, where 0 is maximum value actually. But I am restricted to the up to 45 degrees only. But here The maximum value is actually 90 degrees, right? Sin A is 1 at 90 degrees, but 90 degrees is not in this range, correct? So I will restrict my A to 45 degrees. So this is the right way. This is the maximum value I'll get, correct? So if I put A equal to 45 degrees, okay, uh, in this range 0 to 45, 1 by root 2 is the maximum range. So max K will be 8 by 2, square root of 8 by 2 plus 1, which is square root of 5. This is the maximum possible value. And just cross check where it is applicable. Maximum possible with approximate A equal to 45, then B is equal to 15. If you add 15, then what is the value of this one? 45 minus 15, which is sin 30, okay, plus 2 sin 60. Sin 30 plus 2 sin 60, you'll get the expected value, right? So this is the correct value. Okay. So make sure that you know the equation, but make sure that where you are restricted. Just I want to show, I can directly show this is the answer. But some of you, if you are going through the other possible way, you will get 3 and you may think 3 is the highest value, because 3 and square root of 5, if I compare, 3 is a bigger value, right? So only thing is we are restricted with this 0 to 45 degrees. This is most important. This range of theta is very important here. Okay, this is playing a bigger role. Okay, so this is a very good problem to find the ranges of trigonometric equations. And most of the trigonometric equations and the problems you get in competitive exams is ranges actually. Find the maximum, minimum. These are the typical problems you get actually. Okay, yeah. Next, yeah. Next one is maximum value of f of x, which is defined as cos cube x plus sin square x minus cos x. Okay, so most of these range problems in trigonometric equations, we need to apply arithmetic mean is greater than or equal to geometric mean rule. Okay, only thing is first make sure that your equation is uh, reconfigured into that format, which is useful in that format. Okay, if you see here, if I consider these as three terms, cos cube x, sin square x, and minus cos x as three terms, okay, arithmetic mean is obviously by 3, and the geometric mean is product of these three terms. But I don't get anything special from this product of these three terms, right? Cos cube x, uh, cos power minus cos power 4x plus sin square x I will get, which is of not much of use for me. Okay, so instead I will basically change it slightly so that it is useful for me in that way. Okay, so f of x is defined as like this. I took cos x common, so it will become cos square x minus 1, cos square x minus 1, okay, plus sin square x. This is nothing but sin square x. So if I replace it as sin square x and take sin square x common, then it will become f of x is defined as sin square x into cos x plus 1. Okay. Now I will apply these two rules. 1 plus cos 2a equal to 2 cos square a and sin 2a equal to 2 sin a cos a. Okay. Here 1 plus cos x I have. So 1 plus cos a will be 2 cos square a by 2. Okay. Similarly, sin x is equal to 2 sin a by 2 cos a by 2. Okay, so these two I will apply. If I apply f of x will become 4 times, because it is a square, sin x square. So 4 times sin square x, x by 2, cos square x by 2. And the bracket 1 cos x plus 1 will become 2 cos square x by 2. Okay, which is equal to, if I rewrite them properly, 2 sin square x by 2 product of cos square x by 2 product of cos square x by 2. Now, if you see, if you consider these three as three terms, okay, three as three terms, then sum of this one is arithmetic mean, correct? Then I will get sin square x plus cos square x I can apply. I will get 2 on one side. And other side I have this value. So I will get the range very easily. So now I apply AM is greater than or equal to GM rule on this one. Okay. So if I consider these three as terms, okay, these three are terms, then sum of these three terms by 3, correct, is greater than or equal to, this is arithmetic mean. Geometric mean is product of these three terms, which is sin 2 sin square x by 2 into cos square x by 2 into cos square x by 2 whole to the power of 1 by 3, because there are three terms. Okay, now this is nothing but f of x, right? 4 times of this value is f of x, so it's easy now. This one, this numerator will become 2, because there are 2 sin square thetas are there, 2 cos squared thetas are there, right? This is 2. So 2 by 3 is greater than or equal to this value. If I cube on both sides, I will get 2 sin square x by 2 into cos square x by 2 into cos square x by 2 is less than or equal to cube of 2 by 3, which is 8 by 27. Now this is nothing but my close to my f of x. So f of x is 4 times this value, which is 4 times of 8 by 23. So this is less than 32 by 27. So this is my maximum value. That means, okay. So get to know this AM greater than GM rule and how to apply it in trigonometric equations. This is very important formula. I mean, a rule to apply and derive the ranges. Okay, maximum or minimum values. This is the way to deal. Okay, next. Yeah, this is another kind of trigonometric equation which came in IMO. Cos square x plus cos square 2x plus cos square 3x equal to 1. Find x in the range of minus pi to pi. Okay. So these are the following trigonometric formula we use actually to solve this problem. One is cos a plus b plus cos a minus b equal to 2 cos a cos b. Cos 2a equal to 2 cos square a minus 1, or you can rewrite, which we used this equation in the previous problem also. Cos square a equal to cos 2a plus 1 by 2. Most of the trigonometric equations, one is AM is greater than or equal to GM rule. That is one thing I told you. Second one is whenever you see cos square A, try to convert into cos 2A. Okay. Most of the problems you can solve that. Okay. So remember, this is very important equation. This equation is very important. Both are same basically, just written in different way. Okay. Now let's see how to put it. Cos square x, cos square 2x, cos square 3x is there. All are cos square values. So I will rewrite it into this form. Cos 2x plus 1 by 2, cos 4x plus 1 by 2, cos 6x plus 1 by 2, which is equal to 0. So if I simplify, what I will get is 1 plus cos 2x plus cos 4x plus cos 6x equal to 0. This 1 I will write it as cos 0. Okay. And I am regrouping so that I will get equal angles. Okay. 6 plus 6x plus 0, 4x plus 2x, all are 6x, 6x. This way I will rewrite them as cos 3x minus x plus cos 3x plus x plus cos 3x minus x plus cos 3x plus x. This is I am rewriting each one. If you see cos 2x I am writing as 3x minus 1, 4x, 3x plus 1. Now if you see here, this formula I am applying cos a plus b into cos a minus b. What I will get is 2 cos a cos b, right? 2 cos square 3x. That is 2 cos x cos 3x into cos 3x, which is cos square 3x. These two I will get 2 times cos 3x into cos x. Or I will, if I take 3x as common, okay, if I take 3x common, then what I will get is, and 2 is anyway gone basically because both have 2. So other side is LHS, RHS side it is 0, so 2 is gone. Cos 3x into cos 3x plus cos x, which is equal to 0. Now this also I can convert into same using this formula, correct? So I will convert, this is nothing but 2x plus x, 2x minus x, correct? So 2 times cos 2x cos x. Okay. Now I have a product of 3 cos, correct? 3 coses, cos x into cos 2x into cos 3x equal to 0. So obviously one of them should be 0 to solve this equation, correct? To find the range. So if cos x equal to 0 or cos 2x equal to 0, cos 3x equal to 0. One of this should be, or multiple can be correct answers, right? So if cos a is 0, a is plus or minus pi by 2 plus k pi by 2. Okay, k is the integer here. K is the integer. So you get repetitive values, right? So within this range, now we should be able to find all the values. Okay. For cos x equal to 0, x is plus or minus pi by 2. Okay. If I add plus pi, uh, I will go out of range basically, correct? Pi by 2 plus pi is out of range. Minus pi by 2 also out of range. So these are the only two values I get. Next one is cos 2x equal to 0. So x is pi by 4. Okay. Plus or minus pi by 4. And plus or minus 3 pi by 4 also possible here, right? If I take k as 1, then plus or minus 3 pi by 4 also you'll get. Okay. If cos 3x equal to 0, x is plus or minus pi by 6, I'll get another option plus or minus 5 pi by 6. So these uh, 4 plus 4, 8 plus 2, 10. These 10 are the uh, uh, possible solution set for this equation. Okay. Yeah, next. Yeah, this is another interesting problem in IMO. 1 sin 2 plus 2 sin 4 plus 3 sin 6 up to 90 sin 180 equal to 0. 180 is how much? This is the question. So this is very interesting problem to solve actually. How we will convert into different forms. Okay. See, you have 1 sin 2, 2 sin 4, 3 sin 6. So in the middle, what you will get is 44 sin 88, correct? 45 sin 90. If you see this coefficient and angle are basically, angle is double that of coefficient. Okay. 46 sin 92. And then in the end, you will get 89 sin 178, 90 sin 180. Correct? Now we know that sin x equal to sin pi minus x, which is same. So I will write this uh, 178 as 180 minus 2. Okay, this is, I know this is 0. So I can just ignore it. This is 0, right? Sin 180 is 0. I can ignore it. This I will write it as sin pi minus 2. So 89 sin 2, 1 sin 2. It will become 89, 90 sin 2. Correct? Okay. So I am rewriting 89 sin 2. Then this will become, the previous one will become 88 sin 4. And in the center, I'll get 44 sin 88 and 46 sin 88. So if I add these two, I will get 90. Correct? And only thing remaining is this one alone, standalone. And sin 90 value, I already know it. Okay. Sin 90 is 1. Correct? So it will become 45. So I take 90 common, then I am left with sin 2 plus sin 4 plus dash dash just up to sin 88 plus 45. Okay, now I reduced my main equation, which is up to 180 degrees to 90 degrees. 88 degrees only I kept it now, right? So, okay. So I will write it like this. Uh, I added 90 sin 90s. Okay, so that it will become 45 sin 90s are already there. I'm adding 45 more. So I am subtracting 45 sin 90s. So that this equation will become 2 to 90. Just like here, it is 2 to 180. It has become 2 to 90 now. Okay. Only thing is this coefficient has gone. Okay. Now, this is simple equation. Okay. Okay. You only thing is you have to remember this equation. If these angles are in arithmetic progression, if you see angles are in arithmetic progression, correct? That is sin A plus sin A plus B sin A plus 2B up to n times, then the equation is sin of nb by 2 divided by sin b by 2 times sin of A plus B by 2 into n minus 1. If you carefully look at, this is very similar to the sum of arithmetic progression also, where you will get n by 2 into 2A plus n minus 1 into d, right? So here b is the difference, so it is d. So it's almost similar. Remembering it is easy. You have to remember. It's easy. I will also give I mean, how to solve this formula. Okay, how to get this formula. How to basically sum of all this. How you will get this formula. No? That also I will do it in next. So as of now, you can remember this. Now you have to apply this one, right? Which is equal to 90 times sine of 45. Sine of 45, because you will get here 45 plus 2 times, right? Correct? Total how many terms you have? N terms are 45, because you are starting from 2 and 90, and they are basically 2 for all even numbers, even angles, right? So sine 45, n is 45 into 2 by 2. Why it is 2 by 2? B is 2. Difference in angle is 2. 2 by 2 divided by sine 2 by 2 into sine times A is 2 plus B is 2, 2 by 2 into 45 minus 1 minus 45. This is minus 45. So if I simplify this, Okay, I just need to simplify this. Okay, how can I do this? One is sine 45 by sine 1. Okay, if I see here, go back. This is sine uh, 45, correct, by sine 1 into this is sine 44 plus 2, which is 46. Sine 46, sine 45 by sine 1. Okay, this is what I have. So sine 45, sine 46, sine 1. Division is sine 1 minus 45. Now, how can I do this? I will take 2 inside. So it will become 245 by sine 1 into 2 sine 45 sine 46. Okay, if you see, this is sequential. So it's easy to get, because sum of this is 91, if you see. So this will become, if I apply 2 sin A sin B equal to sin A plus B to sin A minus B. If I apply this will become, what it will become? Okay, sin A plus B, that is sin 91 and sin 1. Sin 91 plus sin 91 plus, so sin 91 plus sin 1, correct? So this will become sin 91 plus sin 1. If I write sin 91 as cos 1, right? Sin 90 plus 1 is cos 1. Okay. Now, if I apply this one, I will get, and if I divide this one, sin 1 get cancelled. Cos 1 by sin 1 is cot 1. So, simplification is this value. Cot 1 degree is the answer of this expression. Okay. You can see it is such a big expression, but finally it is just nothing but cot 1. Okay. So, this is the value, and this is how we should solve. I just now I told you we will give a solution for this problem up to n terms. So, let's solve this one. Okay. So this is the given sum, sine 1, sine alpha plus sine alpha plus beta. This beta is the difference in angle, 2 beta, 3 beta, up to n minus 1 beta. Okay, they are in arithmetic progression. Multiply and divide with 2 sine beta by 2. Okay, both sides. So it will become 1 by 2 sine beta by 2, and each term will get a sine beta by 2. Okay, now next is 1 by 2 sine beta by 2. So this is nothing but cos beta by 2, cos of alpha minus beta by 2 minus cos of alpha plus beta by 2. Okay. This one is cos of alpha plus beta by 2 minus cos of alpha plus 3 beta by 2. Up to last term is this one. Right. Carefully check and write the angles. Then you will know very easily. So if you see, all these values gets cancelled. First one will remain. Second one, third one gets cancelled. Third and fourth and fifth gets cancelled, and only the last one will remain. So this is nothing but 1 by 2 sine beta by 2 into cos alpha minus beta by 2 minus cos alpha plus n by n beta minus beta by 2. These two only remain. Okay. Now, once you know this, this is very simple to solve. Okay. This is what remaining. Okay. Now, I am writing this in terms of 2 sine a minus b by 2 sine a plus b by 2. Correct. So, this is my a, this is my b. Okay. First is a minus b, a minus b by 2 sine a is here, plus b by 2. Okay. Now, if I simplify this, what I will get is 1 by 2 sine beta by 2 as is, then 2 sine n beta by 2, and so sine alpha minus n minus 1 beta by 2. Okay. So, this is nothing but, if I bring it out, I will get sine n beta by 2 divided by sine beta by 2, sine times alpha minus n minus 1 beta by 2. This is what is the proof of that above sum. Okay. I hope these problems are very interesting for you. As I said, I went from easy to advanced problems. So this is useful for everybody from 8th class to 12th class. Hope I'll bring it more problems from trigonometry like this. Yeah, one last problem we'll try. Prove that 1 by sine 2x plus 1 by 2 sine 4x dash 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 up to 1 by sine 2 power n x equal to cot x minus cot 2 power n x. Okay. So let's see how to this. First, let's check for n equal to 1, is it true or not? For n equal to 1, what will happen? 1 by sine 2x LHS is, and then RHS will become RHS will become cot x minus cot 2x, correct? Cot x minus cot 2x. So what is cot x minus cot 2x? Is nothing but cos x by sin x minus cos 2x by sin 2x. So if I take if I multiply this cos x with 2 cos x on numerator and denominator, this is what it will become. Okay, this is nothing but 2 cos square x by sin 2x. This is sin 2x minus cos 2x by sin 2x. Okay, now denominators are same. So I will add like this 2 cos square x minus cos 2x divided by sin 2x. Okay, now whenever you see cos square x, you have to use this formula. Cos square x, you use this. Okay, so 2 cos square x is cos 2x plus 1. If I put that cos 2x plus 1, this will become cos 2x, cos minus cos 2x gets cancelled and 1 will remain. So 1 by sin 2x. This is nothing but LHS. Correct? For n equal to 1, we proved it and we know that 1 by sin 2x is equal to cot x minus cot 2x. Now we know this. Okay, once you know this, it's very simple. LHS is this value. Okay, so if I replace 1 by sin 2x is nothing but cot x minus cot 2x. 1 by sin 4x is nothing but cot 2x minus cot 4x. So keep on writing. So I am left with, if you see all these terms gets cancelled, right? Minus cot 2x plus cot 2x minus cot 4x plus cot 4x gets cancelled. You will left with only first and last, right? And this is the first and last term. Okay. So I think these are all very interesting problems in trigonometric equations. You should know all these tricks and traits before, so that you can apply when some such similar problems comes. You can apply all these tricks and traits. Okay. Yeah. Thank you. I hope I brought some good set of trigonometric problems to you. I will keep on adding more interesting problems which are useful for your entrance exams as well as Olympiad. Thank you. Till then, keep doing math problems.